Okay, I got a little cut off there at the very end, but we're going to continue on with what I was talking about just earlier. What we want to see is, what does it mean that I have a point that's above and below my horizontal asymptote? It's implying that I'm going to have a line going right through my horizontal asymptote, and can that happen? Well, what I'm going to tell you right now is going to sound a little weird, but what I'm going to say is yes, indeed. And if you do a bit of a table of values there and pick maybe, say, negative 0.5 and 0.5 and 1.5, you're going to notice that your graph is going to look somewhat like this. And you say, well, wait a minute, Mr. Gale. This thing's passing through my horizontal asymptote. Isn't this a case where I have something that should not be? And in a sense, that's true, but I guess what I've been saying to you about horizontal asymptotes is slightly off, and I need you to think about this for a minute. Most of the time, what we're talking about when we say horizontal asymptotes is where the graph goes as x gets really big. You notice that's actually the way we're trying to describe it there when we're trying to figure out what the asymptote was in the first place. That's how we're looking at it. What does this thing become slowly? It is different than when you're looking for vertical asymptotes, because it is indeed true for vertical asymptotes that you will not ever be able to touch it. With horizontal asymptotes, what we're talking about more is what we're defining as the limit of the graph. Where is everything headed to? So in the middle, in this case, directly in the middle of this graph, we possibly could have something happening there. We could have something passing through. And I can prove it, because all I have to do is say, well, I seem to have something hitting at y equals 1. Is that the case? Well, let's just do the equation. 1 equaling x plus 5 times x minus 1. I could just write out the whole equation too. I'll just write down the x squared minus x minus 2. That's really what I want to say. So if I wanted to solve this, as you can see, I could just simply bring up the lower equation to the top. And what am I going to end up with? Well, I'm going to end up with x squared minus x minus 2 equaling the equation on the top. And in this case, I'm going to write it the full quadratic. X squared plus 4x minus 5. I'm going to immediately recognize that the x squareds are going to cancel out. And if I have no x squared value, I don't have two different possible answers. So it falls right in line with what I got here. What I'm showing there, what I think I'm showing graphically, is that I will have only one solution. And indeed, this will be true, because look at now what happens here. I'm going to bring my minus 5 over, and that's going to be plus 5 to my minus 2, and I'm going to end up with a 3. And that's equal to the x coming over to this side will give me a 5x, and I will have a solution for y equals 1 at 3 over 5. And if you look at the graph, that's pretty well almost exactly where I am when I'm passing through it, at x equals 3 over 5. So it indeed works. So my suggestion to you that when you're doing something that involves a quad over quad with no common factors is that you get your asymptotes, but you take a moment to figure out what is going on between the two vertical asymptotes. That's very important. For the most part, you're going to be all right with the other ones. They are going to both be across the top, and they're provided that we don't have a negative up here in one of these values, but we're assuming we don't. We're assuming we have two positive quadratics. We should be getting something on the upper side of the horizontal asymptote that then approaches it as x gets bigger and bigger and bigger. So there you have it, quad over quad. So are we done? No, we're not done at all. What do we want to do next? Well, what we want to look at next now is actually the last thing. And this would be the linear over quad. And this we actually haven't even done yet. We haven't talked about it at all. So there really is, unfortunately, there's a good and bad to the linear over quad. It can get really weird looking, and you might be limiting yourself to having to do a table of values in most cases because of the shapes it can create. But there are a few things you can know anyway. And let's just take a look at one. We got y equals x minus 3 over x squared plus x minus 6. And if I had to factor that out, I'd be calling that x minus 3 all over x plus 3 over x minus 2. And in this case, I am no longer trying to consider whether or not we have common factors or not. I have only one question really to ask that can help me out, and it is, can the denominator, that's the worst R I've done in a while, denominator be 0? Is there a way to make it 0? Now in this case, definitely. There's all sorts of things I can make. In fact, so with this case, this is the yes situation. In case of the yes situation, I can get quite a few things. For example, I know some vertical asymptotes. And we've already done this, so this is nothing new. Y equals -3, I'm sorry, x equals -3 and x equals 2. So I can immediately set that up. I got this guy, and this guy. Okay. Now, what else can I figure out? Well, I got my horizontal asymptote. And once again, I'm doing it in the same way I did before. I'm dividing the highest terms. And what is this going to look like in this case? Well, it'll be x divided by x squared. Well, that equals 1 over x. And what does 1 over x become after getting enormously big? Well, it's kind of obvious what it's going to what's going to happen to it. It's going to become, it's going to approach 0. It's going to approach 0. So that means I know already that I have a horizontal asymptote at y equals 0. So as I said before, I should know what happens on either side outside of those two vertical asymptotes. Just like with the quad over quad where I had no common factors, I had to be concerned about what happens inside. The outside I should know, but I have to still be a little careful, because let me look at this now. Say I have a positive x, okay, as x is positive, I'm going to get close to 0 from the positive side. So I know that I'm going to have something that looks more or less, and once again, if I want to get this right, I probably would have to pick a few points. Perhaps x equals 3 or 4, and I probably get some points there, and this would look a little more reasonable about where it's actually going to end up. But let's look at the negative. Now, if this is a negative, now this is what I'm talking about. You have to analyze these graphs to get them right. I got x over x squared. Now let's be careful. It will approach 0. But x squared will always be positive. And x, if it's a negative x, will always be negative, which means I'm always approaching from the negative side. So I'm going to have something that looks like this. So it looks, this is a little different from before with the quad over quad. Quad over quad doesn't give us this shape. Linear over quad does. Now what is going to happen in the middle? Well, I wish I could give you something a little cleaner than saying you're just going to have to plug in some values, but well, that is what you're going to have to do. You are going to have to make some sort of table of values where you have to look at, say, well, what if x is this? What is my y going to be? And I have to look at a few spots here. So I've got -2, -1, 0, and 1 in between there. And those 4 points should give me a pretty good idea of what's going to happen. So let's take a look at some of them. And boom. Okay, I've skipped ahead a bit for you. And you can look through those. You can pause the video if you want and just see, but I've done a few of the points. And what does this look like? This actually looks a little weird. Okay, so 5 over 4, so I'm going to have something around there at -2. 2/3 is going to be around there. Half and half. But even though I'm not sure about it, I can check if I want on one last point, just be certain, and check at what happens at 1.5, just to be sure. And this is where I can really see what's happening. At 1.5, I have a value of 1, 2, 3, and now I really do know what's going on. It's a little funny shape though, and this is where you do need those table values. You can see what's going to happen here. Very different shape. In fact, it doesn't even look like a normal, nice little parabola. It's not a parabola at all, in fact. it looks incredibly strange. So it's lopsided, it's strange, and you just have to be careful about that kind of thing and get it right. So that is the situation of a linear over quad where you know that the denominator can be 0. But what if the denominator can't be 0? What kind of situation would that look like even? So let's see what that, let's give an example here. What if we had, what if we had an y equals x minus 3 over x squared plus 1. Now in this case, well actually here I'll linear over quad, we can see that what happens at the bottom, no matter what x is, it's if I square it, it's going to be positive, and if I add 1, then I'm guaranteeing, no matter what, even at 0, that I'm going to end up with something that's going to give me a positive value. So let's just make this clear. This is cannot, if denominator cannot be 0. So remember, we're not concerned about common terms or common factors, with linear over quad. We are looking for a situation where, well, we can't get 0 at the bottom. So if I can't get 0 at the bottom, this implies that I have no, let me repeat, no vertical asymptotes. There's none. So my vertical asymptote, none. I don't have anything. So I know this graph is going to look entirely different from what I've done so far. Do I have a horizontal asymptote? That's the question. Well, in fact I do. But what is the point of a horizontal asymptote in this point? And the only way of really knowing, by the way, I can tell what my horizontal asymptote is because there's no k value, so I know that this is, if I think about it, x over x squared. Looking at that again, what is the limit? Limit as x approaches infinity of x over x squared. It's going to be equal to 0. So I know I've got a y equals 0 here, y equals 0 as my horizontal asymptote. But what does the entire graph look like? And unfortunately, I have nothing good for you to say. I just don't have anything nice. You have to go through a table of values. Now, what I would suggest, I'm not going to draw it here. I'm going to leave it up to you. What I would highly suggest is look at a few areas. In fact, go from, say, a range of -5 to 5. You know, let me say, what you do know is that you're going to have a limit where the thing is going to get closer to 0, close to 0. So I should see this as my end behaviors. Question is, I do know this is going to be coming from the negative side. I knew this is going to be coming from the positive side. This is going to be happening. What happens in the middle? Try it on your own. See what you can do. I'd like you to find out. It's kind of a nifty looking little graph. So work it out. See what you can find the entire shape looking like. And that will end up being the complete list of all the different types. Now, we managed to do that in 3 videos. I'm going to do one last video after this. Now, it won't be going through the shapes. It will be going through one question, because this was a big one on the quiz, and I know that some of you had a lot of trouble with it. So I'm going to write down that question right now. And you tell me, maybe work it out on your own first and see if you can get it. So here it is. We're going to have, what is the solution to x over 2x plus 5 plus 2x equals 8x plus 15 all over 4x plus 10. So this is my big question, and in my last video what I'll be doing is I'll be going through it in detail so we can know what to do in this case. But before you check that video, why not try it yourself? It is something that you should be able to do. So if you have trouble, then I'll be seeing you on the next video. Okay, guys. Hope that helped. I hope that helped a lot. All right. Talk to you later.